Yes, Tahir, your screen is up. Can you take it to the title page? Perfect.
Yes.
All right, thanks.
Right.
Uh, Attendance. Okay.
So I'll try to dial some other people in.
Okay.
Hello, everybody. Can we do a gentle reminder on the various platform for people to come and join?
Yes, sir. We're on it. We have been sending reminders. Good evening, everyone, and welcome. So we'll be starting shortly. Please give us a few minutes to allow more participants to join. Thank you. As you join, kindly forward the meeting link to your colleagues, your friends, so that they can join this insightful lecture. Thank you.
This is the presenter here. Has he been able to join?
No, sir, he's not here yet.
Okay, it's like he's having challenge. Is there any way we can support him? Hmm. Hmm. Well, Madam Tessie sent me a message that it's having challenge. Madam Tessie.
Good evening, sir. So I think maybe they should send him the direct link instead of the registration link. Maybe that's may
Okay, does
assist.
anybody have the direct link? Maybe forward to Madam Tessie, so that she is the one communicating with him. She can forward it to him.
I think Madam Tessie should be the one to have that link. Yeah, that's
Okay.
my yes, sir.
2 p.m. Okay, that he will join later. Then all of a sudden he said he's having difficulty. So let's see if anybody can see chat him up. I don't know, maybe it's his network. I don't know.
Madam Tessie, I tried reaching you before. Please, I would like to talk to you after this meeting, please.
Yes, I can see our presenter is here with us. Engineer Sylvester, kindly confirm you can hear us.
It seems he's still having a network challenge.
Yes, sir.
Good evening, everybody. Can you hear me?
Yes, loud and clear, sir. We can hear you. Thank you for joining.
Okay, sorry for joining late. I've been in the meeting since 2 p.m. and I have to run out now. I'm sorry about that.
Okay. All right, sir. So we'll get started now. Thank you for joining us. Good day, distinguished guests, industry professionals, and esteemed members of SPE Section 104 Wari. My name is Tahir Moi, and it is both an honor and a privilege to moderate today's much technical lecture. So we are delighted to have you join us for what promises to be a highly engaging and insightful session. And I would like to apologize once again for the lateness in starting this session. So before we proceed, I'll briefly walk us through the agenda for today's session. We'll begin with an opening prayer of the third stanza of National Anthem, then a safety briefing by Israel Chibuike, and followed by the opening remarks by Dr. Oluwaseun Adetuna, then the introduction of our guest speaker by Sylvia and Mora, followed by the technical lecture by our lecturer, Engineer S.Okotie Sylvester. That will be followed by an interactive Q&A section and a key takeaways by Israel Chibuike. We'll then go to the photography session by Anthony Odige, and we'll be closing with the vote of thanks and closing remarks by Engineer Elvis Duruji. So to begin, we'll observe the third stanza of the Nigerian National Anthem as our opening prayer. So kindly unmute your mics as we take this prayer. So, O God of all creation, grant this our one request.
Help
Help us
us
to
to
live in a
live in a
nation
nation
where
where
no
no
man is
one is
oppressed,
oppressed,
and
so
so
that
with
with
peace and
peace and
plenty,
plenty,
Nigeria
Nigeria
may be
is
blessed.
to be blessed.
Amen.
Amen. Thank you. So before we proceed, a few housekeeping and safety guidelines to ensure a smooth and safe session. And so Israel, you'll be taking us through the safety brief. Please go ahead.
All right, good evening, everybody. Please confirm I can be heard.
Yes, we can hear you loud and clear.
All right, thank you. So as we all know, as part of our practices in the industry, we have to observe a safety moment before every session. So we'll quickly, once you're on this call, please do well to mute your mic to avoid interruptions. And if you are making use of your headsets, please ensure you can still hear the fire alarm whatever noise in your background. And please, if you have any comments or questions, please be able to raise up your hand using the reaction, and the moderator will do well to give you the floor. And also always be aware and at alert in your environment. During the course of the program or the session, if you have any comments or questions, please do well to use the chat box using the alphabet C for comments and the letter Q for questions. And also maintain a good sitting position, because I believe we'll all be sitting during the course of this lecture. And finally, once again, remember your safety is your topmost priority. So be at alert and always stay safe. Enjoy the rest of the session. Thank you.
Yes, thank you, Israel. So as always, safety first. So we'll now proceed to the opening remarks. It is my honor to invite the section chairman, Dr. Oluwaseun Adetona, to address us. So the floor is yours.
Good evening, everyone. I would like to welcome everybody to this call. It's not just a technical session. It's a way of giving back from our speaker today. Dr. Okotie had always been tremendous to support Section 104. Even in his busy schedules, anytime we call on him, he's always making sure he participates. He's always putting himself in the forefront to ensure anything we ask him to do, he's always doing it. So, Dr. Okotie, I would like to say a big thank you to you on behalf of Section 104 for all you do. We are very grateful for creating the time to be available for us today. I know this schedule has been tight for you, but yet you still try to see how you can create a time for us. So we are quite grateful for that. And to our young professionals, distinguished members on the call, I want us to know that it's an honor for us to be on this call. Please, let's sit back, relax with our pens, our recording tools, and make sure we enjoy the presentation, and also pen down some questions for the presenter, so that at the end of the day, you can make it more interactive with our questions and answers section. Please, I want to endeavor, if there are students on the call, it's also good for you. This is a means of networking and also gathering information in some specific technical area. So at this point, I would like to hand over the floor back to the moderator. Thank you, everyone. Program chair, we are proud of you for making sure this day come to pass. Thank you so much. Thank you.
Thank you. Thank you very much, sir, for those inspiring remarks. And as your advice, please, let's keep it as interactive as possible, ask questions. And so we'll now move to the introduction of our guest speaker. I would like to invite Sylvia Anwura to introduce our distinguished speaker for today's lecture. Sylvia, over to you.
Good evening, everyone. So please let us make welcome our guest speaker. Is the person of
Sorry, Sylvia, we can't hear you.
Hello, please can you hear me?
Yes, it's better now. Yes, we can hear you now.
Can you hear
Thank
me
you.
now?
We can hear you now. Thank you.
Okay. Good evening, everyone. Okay. Good evening, everyone. Please also make welcome our guest speaker, in the person of Engineer Dr. S.Okotie. He's a reservoir engineer and an MD consultant of KPML. Thank you. So, Okotie Sylvester is currently working with Crown Marine and Petroleum Services Limited as a technical assistant to the Chief Operating Officer for the development of Ogambo PPL 213 field. He was a senior reservoir engineer with Hilltop Global Oil and Gas Solutions Limited on Alamo PPL 224 Marginal Civil Development. He is also a lecturer at the Department of Petroleum Engineering. He has been involved in the conceptual basis of design for several gas utilization projects. He has delivered several trainings across the oil and gas industry value chain. He holds a Bachelor of Engineering degree in Petroleum Engineering, a Master's in Engineering and PhD degree in Reservoir Engineering from the University of Port Harcourt, Nigeria. In his undergraduate degree, he graduated as the best student in petroleum engineering before joining FUPRI.
Hello? Is it from my end? Can anyone hear me?
Yes, we
we
can
can
hear
hear
you.
you.
But I
Tahir,
can't hear
kindly, Tahir,
the
kindly
lady.
finish up the reading the speakers by maybe Silver is having issues with her network.
Okay, just
Thank you.
yes. So our speaker today holds a BEng degree in petroleum engineering, MEng and PhD degrees in reservoir engineering from the University of Port Harcourt, Nigeria. In his undergraduate degree, he graduated as the best student in petroleum engineering. So before joining FUPRI, he worked for ExxonMobil Nigeria Unlimited and Lenswell Oil Services Nigeria. He's a registered professional engineer by the Council of Regulation of Engineering in Nigeria. He's a member of SPE and a member of the Nigerian Society of Engineers. He is also a registered environmental specialist by the National Registry of Environmental Professionals. Our speaker for today is an author of several books published by Springer Nature, Elsevier, and other publishers. He is currently a consultant at other oil and gas industries on oil and gas field development, providing end-to-end solution and manpower development, and he can develop any training content across the oil and gas industry value chain for new and experienced employees. So reviewing competent person reports, developing the basis of design for oil and gas facility basis of design, delivering of EPCIC projects, and etc. So his area of specialization includes well test analysis and interpretation, reservoir simulation, petroleum economics, recovery methods, mathematical modeling of engineering systems, computer programming, and applications. Wow. Now, Okotie Sylvester is very well rounded, and sir, I would like to appreciate you for having time to join us and present this lecture today out of your busy schedule. We really appreciate you. Thank you.
Thank you, sir.
So, sir, without further ado, please join me in welcoming Engineer Okotie Sylvester. Sir, the floor is yours. You can proceed to share your screen and start the lecture.
Just confirm you can see my screen.
Yes, we can see it.
We can see it.
Okay, once again, I appreciate everyone on this call. Please, can you just give me an heads up on the timing of the presentation so that I will know how to run?
So you have 25 minutes.
Okay, thank you. Okay, we'll just try and make it practical and interactive as possible. Luckily, while engaging the session chair on this, I was actually in the field supervising the BHP survey. So It could just be raw information coming from the location or the field, attaching the theoretical concept alongside. So we are looking at BHP survey, estimation of some fundamental well and reservoir parameters. So it's very simple. This BHP survey, though, is a mandatory operation, but no specific timeline has set to when to carry out that operation by the regulator, which is NUPROC. But it's very critical you will carry out this operation in our wells just to understand, because a reservoir you don't understand, it's difficult for you to carry out a performance evaluation on that reservoir. It's very key when you want to do your field studies, field development, you need to acquire this data. Basically, the BHP, which is bottom hole pressure survey, is a simple test that we conduct. What we try to do is to run gauge or gauges in tandem into the wellbore down to your point of interest, though you cannot run it down to your mid perforation or directly into the reservoir. You just maybe you suspend it and leave it there at the SN depot. Then when you look at the full spread of the BHP survey, what you are trying to do here is to measure the variation, the pressure variation with pressure and temperature variation with time as you run in the hole. This you can do while the well is flowing or when the well is shut in, either of them, or you run, we have what we call FG, BU and SG. FG flowing gradient, the well will be flowing. You shorten the well maybe 24 hours, 18 hours, 12 hours, depending on your program. Then that's the build up to allow the pressure to build up. Then you come in after the 24 hours, 18 hours, you pick up your gauge and run your static gradient out of hole. So like I said, this test is required by the commission before you carry out, though you need to apply prior to the execution of this job. You apply to the commission and you pay the statutory fee. Then you now get the approval for you to go and carry out this BHP survey. So it's very critical to us as engineers or reservoir engineers for us to actually make informed decision of our wells. Vis-a-vis, you might want to use it to optimize your gas lift system. You want to use it as input data into your reservoir simulation, reservoir management. You want to try to optimize your completion efficiency. So, but the good thing about this is that this data that you acquired is not only resident with you as the operator. Once you are done QAQC interpret this data you will also submit to the commission. So it's mandatory after you get the approval, you acquire the data, QAQC interpret the data, the end point you will also submit back to the commission. So these are some of the objective of carrying out this test is to accurately determine on real time the pressure temperature distribution as you run into the reservoir. Though I'll show us, we will run it to our SN, then we'll now do what they call datum correction, because you cannot run the gauge beyond the SN. So let's say the SN is at 12,000 feet and your reference point, maybe your mid perforation is at 12,300. So it means that between 12,000 that you suspended the gauge and the 300 that is there, you need to record the pressure that is at the sand face, which is of paramount importance to you. Perhaps a new well that is just undergoing extended well test, you want to carry out a PVT analysis. They need to know the mid perforation, the pressure at the mid perforation. Without the BHP survey, they cannot get that. So you want to extrapolate to that point. So you want to know the distribution of the fluid static or dynamic, why the well is flowing, why the well is shorting. You want to know the distribution of the fluid from maybe you zero your depth at your tubing head angle, then down to your mid perforation. You want to know your pressure distribution, your temperature distribution, as in vis-a-vis the flowing gradient. So you want to use it to acquire, though basically you're going to get pressure, temperature, and time data. But with this data, you'll be able to determine some critical parameter like the skin, the permeability. You want to know the average reservoir pressure. You want to know the boundary condition, what is happening at the boundary. You have your reservoir is infinitely acting, or if it is the boundary has been seen, or you want to know what type of boundary, if it's building up to steady state or pseudo steady state. All these are things you want to determine from the end point of the result. So another key thing again, you want to use to verify your current status or the schematic of your future intervention job. You know, perhaps the well is not delivering optimally. You want to carry out an intervention. So with this information, you'll be able to guide into your future intervention job. So these are some application of the derived information you get from the BHP survey. One, reservoir characterization. You want to use it to know the initial pressure. Though during the spotting, the drilling of the well, by the time you get to your pay zone, it's assumed you run any of these open hole tests like the DST, which is the drill stem test, the RFT, the repeat formation tester, the MDT, and the likes of others. You could pick your pressure because the DST2 has a sample cacher for you to pick sample for your PVT analysis. It also has a gauge, temperature and pressure gauge under it that records your pressure as you go down. So with that, you can actually determine your initial reservoir pressure. But going from there, what you now need to do when you now come to run your BHP, maybe annually or biannually or quarterly, you will now need to get the average reservoir pressure by shortening the well, maybe 18 hours to now know the average. So with that, you can get the fluid contact, the permeability for the well performance. You talk about your productivity. You know, productivity index, you're already looking at your rate to draw down, your skin factor, you are looking at your pressure drop over time. You want to use to ascertain the drive of your reservoir, if your aquifer is strong or weak, if it is gas cap. Though at the boundary, when you do your interpreter, you know if it is gas cap and the likes of others. Or perhaps for interference, you want to check the effect of one well if they are communicating with the other. Meaning, if I flow this well too much, what will be the pressure response, the effect on the nearby well since there is an interference? So you want to use it to check your equipment design, if your gas lift is performing optimal, if actually where your operating valve is actually the deepest point. All of these are just key information you need during this survey. So I don't know if I'm too fast. Can I get that confirmation if I'm too fast?
No,
I
you are
think
not
the
too
pace
fast.
is okay, sir.
Okay, now we have different types of BHP tests that we run. Depends on the information you want to get. That's what drives the type of test. Perhaps I want to check if these two wells are communicating. I don't need to run the build-up test or a drawdown test. Simple test for me to run is just to do an interference test. You allow one to use one as an observation well. You put the gauge there. While you will be disturbing this one here, you will be working on the active well. So you are just observing the pressure response with time in the observation well. So the first one here is the build-up test. For you to do this test, the ideal scenario is that you must have flown the well for a period of time. Once you flow the well for a period, you flow it long enough. So once you flow it, you will now have to shut the well in. So that's why you are seeing this part you are seeing, this is the drawdown. The well is flowing, and you can see the rate on this. This is the pressure profile and the rate profile. This is, you have your drawdown, and immediately you see this rate comes down to 0. The well has been shorting at this particular time. You record it, and this is the well now building. So this is now your build up is building to, meaning from, say, this 60 1 hour to one, that is a minute. In terms of minutes, that means another 1 hour you have the build up. So this is how the pressure build up is. So with this, you can, with this region, when we come to Bordeaux, that might be beyond the scope of this presentation, to do the interpretation. How you will now determine key property to know if the well was tested and the well got to the boundary of the reservoir, or it is still an infinite acting that the reservoir has not seen the boundary. So it depends on the program of your test. So basically, for the build-up, while you run the gauge in the well bore, the well must be shortened. But we said the ideal scenario is that the well must be flowing for an appreciable number of time before you short the well in. So, and mind you, we are not doing a multi-rate test. So you have to use a constant production rate to flow the well before you short it in, so that we will not have some disturbance, some segregation, and all this stuff that will affect your data. So this is for build-up test. Then the next one is follow-up. It's just a counterpart of a build-up test. While the well is shorting, you are still injecting fluid into the well bore. So once you do that, you now have to drop, release, and see how it drops, the pressure drops. So which is now the follow-up. It's a counterpart of the build-up. It's just the difference there is that while that is happening, the fluid is being injected into the well bore. So the next one is drawdown test. This test is basically you run your gauge in the hole while the well is flowing. Mind you, the essence of this, you want to measure the sand face pressure, the reservoir pressure. But like I said, you cannot run the gauge down to the perforation, so you suspend it and do what they call datum correction. So this is the same thing. Before you open the well to flow, you must have shut the well in for a good period of time before you open the well to flow. Usually, we will give, say, 3 hours stable flow. Let's achieve 3 hours stable flow before we shut the well in. I mean, before we open, that's for build up. Then you flow the well a number so that you have a stable flow before you shut it in, and you shut the well in a long period before you flow the well. So it's the same scenario. So this period is the period of where you shut the well in, the well is not producing. Then this is when you start your flowing gradient. You open the well to flow on a stable rate, not changing your choke size, because if you are changing your choke size, you are doing a variable or a multi-rate test, but we just need a single rate test. The next one is injectivity. Like we have a counterpart of build-up test that is a follow-up. We also have a counterpart of drawdown test, which is injectivity test. So it's still conducted on a single well, while the fluid is still injected at the same time, just to measure the sand face pressure. Then the next one is the interference test. You can see this is a well here, the observation well. That's where you run the gauge. You can see this gauge here, and this is the active well, the well that is flowing. For this well is flowing at 450 stock tank barrels per day. So you monitor the activities of this well from this observation well. So this is the well you are using as observation well, and this is the well we are using as active well. So usually when I conduct trainings for people in the oil and gas industry and I give illustration, I will just tell them that, okay, this is just a simple analogy. I am here in Lagos, perhaps. My wife is in Warri. If you want to check that there is continuity between the two of us, in Lagos, there you slap me. If you slap me and unconsciously in Warri, my wife will just be feeling some signal about me. It tells you that there is a communication. That means if you slap me too much, my wife will be affected here. Her performance might be dropping here. So once you see that these two ways are as you are producing from here, this well is affected, you know the two of them are communicating. So you now need to be very careful the way you produce. If not, you will deplete or you will drain this, the high pressure drop on this, vis-a-vis, or it can be vice versa. You can see these wells that are linked. If I open this well now and these two are connected to it, you will see the pressure drop that will happen in this well 3 will be the pressure drop due to the well 3 production, and the pressure drop that will come as a result of the production of well 1 and well 2. So it's not going to be only your own pressure drop here. It's going to be with respect to addition of this and this well. So that's where you have a case or you want to check for sound continuity. And sometimes this test, we do it to check for sound continuity. If this sound is communicating with this nearby sound, so you just want to check if there is continuity. So this one is more or less is a pulse test. This one is variable rate test. You'll be changing the choke size. As you change the choke size, either increase or decreasing the choke size, you just be measuring your test. It's just more or less like a type of interference test. But this one, you are changing the choke size. You change, you pause, you change, you pause. That's the pulse test. Is you can see there. I believe after now we'll share the slide so that those of you that want to take a look at it can have access to it. So aside the normal test we do, we have the auxiliary test, which the first one is the flowing gradient test. So what it means is that while you run, you don't run straight down to the well bore. What it means is that you run after 5 minutes, you can set your pressure gauge to be reading 5 minutes. It means that if you run after 5 minutes, you record your pressure. You take your reading, it will measure. So you take that when you stop. After another 5 minutes, you go down again. Wait 5 minutes again, you go down 5 minutes. While the well is still flowing. So you now need to, before you do all these tests, the program between the slick line operator and the asset owner, you now need to sit down a collaborative meeting because they need to understand your well schematic to know what you have in hole, the kind of restrictions, the kind of tubing, the kind of pressure they are going to experience so that they don't lose their tool in hole. So if they have a high pressure well, that means they should be able to build up the stand to withstand the pressure so that they don't lose their gauge in hole, or they don't have the well push the gauge and start throwing the gauge back to the surface. We don't want to have such scenarios. So when you have all of this, you run your program and you look at your web profile to know, oh, we want to see what is happening in this period. So you now have to determine the number of stops till you get to your final survey point. So this you do at this different stop for 5 minutes, depends on your timing. While the well is flowing, it takes time. If you do for 5 minutes and you are going to 14,000, you know, and you are doing for 500 interval, maybe you do some places you want to see what is happening. Maybe you have SCSSV, you have some form of valve, gas lift mandrel. You want to see what is happening within that. It means that the stops will be more, and it will, the more the stop, the more the time you spend in such survey. So what you are trying to do with this, you want to understand the pressure distribution along the wellbore. You want to actually use it to do reservoir performance. And these are the objectives of carrying out the flowing gradient. You want to determine the bottom hole pressure, flowing bottom hole pressure. You want to estimate the gradient of the fluid. You want to evaluate the multi-flow phase behavior. You want to determine the wellbore problem. Perhaps there is liquid loading. You have a restriction. You have a WASP. we have a case that we did. We ran in a survey, and while we were going in, we realized that the gauge was sitting. It's as if the gauge has gotten to the final survey depth. And when we looked at the well schematic critically, we realized that there is no restriction. There is nothing that is in that part. But how come the gauge is sitting there and it's not going down? So it could be you have WAS building. If it's a gas well, you have high drift along the line that have formed that restriction. You know, before you run your, excuse me, before you run your gauge, you have to do what they call a drift run. You run a gauge cutter down the well to ensure that you have a clearance to your final survey depth. If you don't have a clearance, there is no way you would deploy your expensive gauge down the hole. So the drift run on static and the drift run on dynamic using the gauge cutter. So by the time we use the gauge cutter, we run in, we realize that while we are gearing to see, and we're able to break through all those hurdles. Immediately we break through all those hurdles from zero depth to the 12,860, yes, 860 feet of the final survey depth. We realized that there was a pressure surge. There was a surge, volume. Gas started coming out, condensate started gushing out, that it overwhelmed the facility. So it means that the gauge the gauge cutter that they ran in actually freed those WAS, those hydrate, those things that are serving as a blockade on the well bore. And what we realized, a massive flow, they have to cut in, knock down the choke size, bring down the well to allow the test to commence. So these are some EPOPs you can use to detect wellbore problem, the restriction for gas lift valve optimization. Sometimes I think we had a section. I'm also a resource person in Chevron training center in Topcom. I handle their gas lift optimization. Now we've had a well that while they inject, you see the gas, they are not, no production, nothing is happening, but they are injecting. So looking at it, it's a case of a recycling process. That means where the operating valve is not supposed to be the deepest point, that position it is. It means that it needs to go further, deeper into the wellbore. So it is not able to aerate the fluid because that is supposed to be part of the unloading valve. So it means that that well is now a candidate for walkover operation. They need to go down, retrieve the tubing, and redesign to get the deepest point so that the gas will be aerating the fluid close to the reservoir, because you are putting it at a particular section. It's just aerating that period, that area, unloading that section. But under that, below the operating valve, the fluid hydrostatic is still more. So the fluid cannot come up. So the gas is just recycling, passing through the mandrel, the valve, to the wellbore, to the surface, going back up and down, to or fro movement. So such well is now a candidate of walkover operation. So you can use it to actually optimize your gas lift system, determine your well productivity, or you get your pressure PTA, pressure transient data, so that you can do your performance evaluation, or you do your reservoir study, or you want to optimize your production. Because when you say optimize production, if you look at the DASI, for those of you that PE, you are familiar with the Darcy flow equation. Let's take, for instance, the radial flow for oil field unit. You have the rate is equal to 7.03 times 10.08 times 10 raised power minus 3 kh, change in pressure, all over mu, formation volume factor, lane, radius of the reservoir to the radius of the wellbore, plus skin. So that skin there, if you run your BHP survey and you characterize that based on the value of that skin is positive and is high, it means that if I reduce that skin value, what will happen to the rate? Will the rate increase or not? So that is a form of optimization. Are you going to stimulate the well, introduce acid Are you going to increase the effective permeability to break guard because the permeability from your test is low? So these are some data you generate that will give the ROE, the reservoir engineer, an insight to take an informed decision. This is the case of a static gradient. This test you will not do. Why this test now is that when you get to your, while the well is flowing, you run your gauge in the well bore. You want to do a build-up test, you will now have to shorten the well and leave the gauge to stay 24 hours, 18 hours. Then when you are going to pick the gauge is when you run this static gradient. As at that same time, the well will still be short in. You will not be doing the stops while you are coming. So you could see here that you can see this picture. Can you see the picture on my right hand? You can see that this white, you can see that this gradient is very light. And if you do the evaluation, do your gradient stuff, you see that it's between 0.01 to between 0.1 or 1 something, which tells you typical gas gradient. So when you do that plot, you see this, you now say, this is the liquid level on the well bore. And going deeper, is the well not loading? So do you need some form of unloading? So all these are things that you now know. Do you need a coil to come in to unload the well? So these are some information that you get that will give you an insight. And these are basically some of the tools that we use. First thing of which you cannot do any intervention without a BOP, blowout preventer. You can see this is an operation we did somewhere. This is the lubricator. And this stuff you are seeing here is the stuffing bus. So that is what prevents the fluid from your well bore while the well is flowing through your wing valve from coming to the surface, is this stuffing bus. Though we have some cases that will see minor leak, will see leak. So you have your hand pump to pump close so that it will close fully. Sometimes you see gas gushing out. So you also need to arrest it. So this thing you are seeing by one of the operators is an operation that I was part of. This is the gauge that is running O. This is the upper gauge and the lower gauge. So you have a 2-feet pipe separating them. And these are some of the, this is the gauge. You can see it here now, clearly. These are the batteries. So you have the gauges here, and this is the different accessories connecting them. And this is your gauge cutter, other wire line tool. You have fishing tool, perhaps in case you lost any gauge in hole. And this is the schematic. You can see the way it is on the sketch on the wellbore. So you have your gauge. This is your gauge. You can see this is the perforation, the area you really want to test. You want to determine the mid perforation, the reservoir pressure. So since the gauge cannot run in here, you now have to run the gauge and stop here. But you need this value. You now have to do what they call datum correction. We now need to extrapolate and now calculate the pressure down to this mid perforation. So this is the BOP you have seen. This is the lubricator, and this is your stuffing bus. Then you have your wire line unit, which is your PCE slings. You have your pump, panel pump. You have your stem. In case I'm running this gauge in O, and the pressure that the well is pulling this gauge back to the surface. So I have to add stem behind it to give it weight, every weight, so that as you go in down, the pressure cannot pull it in. And this is your line, your slick line. This is the line. And this is your loading cell that tells you the weight, the pressure, which is in your console, your multi-decker unit in your console that you are taking your weight reading. And this one is installed close to the where usually we use chain to chain it to this stuff so that we can put this A pulley within this, so that you can, this is where the wire will be going in and coming out. So it goes in through this stuffing bus. And like I said, this stuffing bus is usually pumped with manual pump to ensure that it is sealed completely, so that immediately you open your master valve, because while you are entering, you deflange, putting your master valve, your swap valve will be fully closed when you remove the tree cap. Not until you are ready and sure everything is true. You don't open your master valve, because if you open your master valve, the fluid is free to air. It will just gush out. So, but with this, once it's open, this stuffing boss is able to hold it to ensure that the fluid does not come to the atmosphere, it's contained, and it goes only through the wing valve. So that is the way the stuff is. So this is the data acquisition. For the data acquisition, like we said, you start your surface preparation. You try to make up your lubricator, because this one, you are saying it comes, the lubricator, you are seeing here, this full stop is not one stack that you bring. You have to make it up on the surface, put all the different devices. You see your loading cell, you make all of them, you go to the well and stab it there. That's where you have your surface rig up. You do your rig up on the wellhead. You have to stab your BOP on the well, then you stab in your lubricator, put in your A pulley, your loading cell, connect to your system. So once you have done that, like I said, you don't run the gauge at first, because you might get a restriction, or the gauge might be stuck and you don't want to lose your expensive gauge. So you do a drift run. You run something attached, instead of this gauge that will be there, it will be this gauge cutter. You put this gauge cutter, you attach it to the stem. This is the stem. You attach it to the stem so that you run in hole. So once you run in hole and you get to the final survey depth and you don't have any restriction, you will not on static. That means the well is shorting. You will not do the same thing again while the well is flowing. You run it straight. Maybe you might not get to your final survey depth. If you have gotten to your final survey depth on static, 12,000 feet, maybe while you are doing your flowing drift, you can run to 6,000, 5,000, depending on your alignment with the operator. Once you get there, that means when you deploy the gauge, when the well is flowing, you will not get that stress or issues and all that. So you do that. After you do that, you run your flowing gradients by running in the gauge. At that time, you will not make up the gauge. At that time, you make up the gauge, you will now run in O. So when you run to the fluid gradient, you don't shorten, immediately you run to your final survey depth, you don't shorten the well immediately. You wait a while, maybe 3 hours, 4 hours, to just give a time period before you will now short the well in. You can short it in within 18 to 24 hours. Then when after time is very critical, you ensure you record the time you shorten the well. Though you communicate to your operator so that they are not expecting fluid at the facility, you shorten your well. Immediately you shorten your well, record your time. You will not record the time you will come to pick up the gauge back. That is when you will not do your static gradient survey. So you will not do your static gradient survey. You will not pull out of the hole. So once you are done with if it is 2 arm, fine and good, you swing to the next arm if it's a dual completion. But if it is a single string, you have to rig down and open the well back to flow and let the operators, they start producing money. And maybe you acquire that data, you don't throw away the data, you have to QA/QC the data to ensure that it follows the normal trend and it is usable. So if you QA/QC the data, we run the 2 gauges in tandem. So we have to do a QA/QC on the pressure difference. The gauges are separated by 2 feet. It means that if the lower gauge is recording 3,000 psi, for instance, and the upper gauge is recording 3,200 psi, it means that the 2 feet multiplied by the gradient of the fluid within that region is what gives the additional pressure. So if it is not consistent with then it means that one of the gauges is faulty. One of the gauges is faulty. So you will not know which of them is faulty. So you want to discard that data and do a rerun. So based on experience, if you do the plot and all, if the data is not usable, there is no need going ahead to do your interpretation, because whatever you are going to interpret is going to land them into trouble. Because I can tell you for free, sometimes we've seen some cases, some people will run saturation log, they will run several stuff, do the interpretation, and they will use the result to go and do a walkover, do an intervention, do this. At the end, they will eat dry hole, they will run into troubles. So we don't want such scenario. That's why it is key for us to QC the data before we do the analysis. And these are some of the inputs. Like I said, the well, physical and geometrical data, you need to know how the well is drilled so that you know you are going to a deviated well, an horizontal well, or a vertical well, and what are the jewelries that are along the well bore. So for you look at your well schematic, you look at everything that you have there. So you need to, I see somebody hand is raised. Kabi.
Yes, sir. Sorry about that. We're running out of time for the lecture. So I know we didn't stand up. We didn't. Yes, thank you, sir.
Okay, let me round up. So these are, once you want to do the interpretation, these are some of the data that you need as input. You can use any of those well test analysis to do the Sapphire Pan system and the likes of every other commercial software. And when we look at the interpretation, we look at the web model. We'll not go into detail. We look at the reservoir model, and we look at the boundary condition. Is it a steady, a constant pressure boundary, closed boundary? Is it a fault? Is it a ceiling fault? Is it a parallel fault or a perpendicular fault? Is it an intersecting fault? So we want to look at the boundary condition, what is happening around the boundary. Then this is just the datum correction that I told you guys. You cannot run the gauge down, or you have to do a datum correction. You need to pick a datum point. Usually we do the mid perforation. So you look at the way the well was completed. What is the top of the perforation? What is the bottom? Add them together and divide by 2. Take that as your datum point and use it to do your datum correction so that you cannot correct the gauge reading at the final survey depth to the pressure mid perforation that you are interested in. And this is just a way to go about that. And this is just some interpretation how to do a manual estimation of this data. You can use Excel to do your static gradient analysis, your flow gradient analysis, determine the fluid contact, calculate your your datum, your mid perforation pressure, and the likes of others. So this is just a simple test. You can see this. No, this is just, we are already doing interpretation. Just telling you this well, they flow this way at this rate. They drop the rate again. They flow this way at this rate. They shorten the well at this point. You can see this is a rate. They increase the rate. The well draw down. And at this point, they shorten the well for build up. You can see the build up time from here to here. And the well builds to this. They open the well again. There is you see they have to what? Drop the rate. This is not a multi-rate. So if I want to do my interpretation, this is where my interpretation is. For me to get my key permeability, skin, my average reservoir pressure, damage ratio, productivity index, flow efficiency, and the likes of other parameters is within this region. So I think because of time, I will pause here. I think we'll cap it up here. Thank you. I'll wait for your feedback, comment, and others. Thank you.
Oh, thank you very much, sir. A technical lecture indeed. Sorry for rushing you towards the end of your presentation. That was very insightful. And as someone still building knowledge in this area, it's great to learn from someone with your experience. So participants, kindly send in the virtual claps, please. Thank you very much, sir, for that presentation. Yes, I can see the claps coming in. Thank you, thank you, thank you. So next on our agenda is the question and answer session. But if there's any section director on the call, kindly unmute your mic just to say a few words of thanks to our presenter.
Well, I'm on the call. I don't know if any other person is on the call. Good evening, all. Am I allowed to speak?
Good evening, sir. Yes,
Yeah,
go ahead,
section
please.
director, you can go ahead.
Okay, yeah, I want to. It's always very interesting listening to Dr. Sylvester Okotie, and I'm always very passionate because it's like when somebody is touching your very sensitive spots anytime he gives his lecture. So thank you very, very much for a detailed lecture on carrying out buttonhole pressure survey. Yeah, I would just like to just add one or two things if there is time, but it's not really like taking your time so much. Um, yeah, he was talking about the stuffing box. The stuffing box is a primary barrier. I just want to mention that so that you get once the well is live, because it comes out in some questions. Most IWCF question is one of the major questions that they ask. So the stuffing box is a primary barrier, meaning that it's one of the key things that is stopping your well pressure from coming to the atmosphere. Yeah. Then again, I just want to mention he talked about a lot about static gradient survey and flowing gradient survey. Another thing I would just like to mention in a static gradient survey, just like he mentioned, once you are doing your build up, if you are doing your build up or doing your static gradient survey, once you have pressure leak, especially from your stuffing box or from any other place, it's going to affect your result. So it's very, very important for you to make sure that you don't have a pressure leak from either the stuffing box or any other place. You know, then I think, well, let me just leave it at that. But a very, very interesting lecture. Thank you very much, and God bless you.
Thank you, Engineer Edward, for shedding light on that. The time was just not enough. I'm sure Engineer Okotie would have shed more lights on all of this. Thank you once again. Participants, kindly send in your questions in the chat box, and if you have a question you'd like to ask, you can also raise your virtual hand. Okay, I can see one hand up. Engineer Christian, please unmute your mic and ask your question. Thank you.
Yeah, thank you very much. So I want to appreciate the presenter for an excellent presentation. He's one person I've always looked up to based on his wealth of knowledge and how he deals with subject matters. So my main question is quite really simple. Now, with respect to some of these aspects that they conduct in the field, I wanted to ask from the regulatory standpoint, what are the regulatory requirements and what are the benchmarks, both for the IOS or maybe for the multinationals? Are there any regulatory framework or can anybody just move in to get the job done? I'm asking that personally because my company is actually looking at something towards that light. So I would like more information on that. Thank you.
I think I can come in. Thank you for that question. This industry, we are highly regulated. And for you to carry out this service, you need to obtain first from the commission. You will need the permit to give you access to carry out this particular service in the industry. So once you get that permit, then you are good to go. Like I said, you don't just go ahead to deploy the service in any of the location. The asset owner, they need to make a formal communication and application to the commission, and they will give you the approval. You have to pay your statutory fee. But for the service provider, you need to get your house together because they will request that gauge you are going to run in. It has to be calibrated. You need all the certificates. You need all your wireline to be updated and the likes of others. So you need all of these, but you need to first secure your permit to carry out such service in the oil and gas industry. So it's very easy. You can go to the commission's portal. You can register and do the minor or tiny payment there, and you start seeking for job if you have the prerequisite experience and the JCC for previous job. Thank you. Sorry, I think my boss hand is up. Can you?
Yes, I can see Dr. Eddie's hand is still up. So can you unmute your mic and ask the question?
Sorry, I didn't know my hand is still up. Okay, let me just still add a voice to what my very revered Dr. Okotie just said. Again, yeah, one of the things for you to carry out a PHP, like he said, you must get permit, you must apply for the permit, and your client must request for it. It's usually done twice in a year in most field locations, twice in a year, so that with your PHP and your MER test, then you are actually allocated, volumes that you can produce from a well. So they are statutory, former DPR, that's NDPR, what was their new name now? They require you to carry out as a regulator. As a regulator, they require you to carry out this activity on your well, at least supposed to be twice, but most times they do it once on the well. As I speak now, I'm even on the field running both an RST and a PLT on E-line, which is almost like a little more advanced, is logging a little more advanced of what, Dr. Okotie has been telling you about. So that's just it. So you really need permission from the regulatory bodies. That's former DPR. Then, of course, the company must tell you, we want you to carry out PHP on these wells. These are the stops that we want you to, take your readings from, and so on. Yeah, thank you.
All right, thank you, sir. So I think it's okay with you. We have time for 2 more questions. Sorry, we didn't start on time. So the next question is from Amos Agbodoma. So he says, thank you very much for the presentation, Dr. Okotie. My question is, during your lecture on data acquisition, you mentioned running a static drift to final depth and then conduct a flowing drift to determine depth. Can you throw more light on that, please? Do you mean during static drift, the well is shut in? And if yes, how is the drift running hole, sir?
Okay, thank you. It's simple. You, by default, you are just supposed to deploy your gauge, or your gauge is downhole, but you don't know what is in the wellbore for you. You don't know if you will be able to run the gauge to that. So you run that inexpensive gauge cutter. So if you have WAS restriction on the wellbore, it will tell you that you cannot run your gauge downhole, because if you lose that gauge on the in hole, it's very expensive. Like while we're carrying out the survey, the guy with the gauge is as if he's sleeping with the gauge, and he will tell you that if he loses that gauge in the hole, he will just run and don't go to his office. So what you do is that you check the well, run that gauge cutter, you shorten the well will not be flowing. You try to run that gauge cutter down to the final survey depth you have proposed. That is the static drift run. You just run it, you are not doing any stop, you just run it continuously till if you are able to get free access to where you will keep the gauge for 18 hours. Then you will still pull out the gauge while the well is shorting. You will not run the gauge while the well is now flowing. You are receiving product in the flow station. So you will run the gauge too while the well is flowing. So these are the static and flowing drift run. You are not taking any record. It's not for pressure record purpose. It's just for you to get a free way to your final survey depth. I don't know if that answers your question.
Amos, your hand is up. Can you quickly ask? So we are running out of time.
Okay. Thank you very much. Dr. Okotie, thank you very much. But I want to understand something. You said the well is shorting. Maybe I'm not getting the concept of the shorting. When you mean well is shorting, you open you close your master valve. That I think that's what I understand as you shorten your well.
Yes.
That's what it means, right?
Yes.
Okay, no problem. I get it now, sir.
All right, thank you, sir. We have one more hand up here, then the others are in the chat, so maybe we'll reach out to those in the chats while we wrap up today's session. But Akatugba, can you please unmute yourself and ask your question?
Yeah, good evening all. Thank you, Dr. Okotie, for this lecture. I just have one question to ask concerning the loading of oil. After loading the well and you are done loading the well, then they shut in the well. They shut in the well. Then after 24 hours or maybe 48 hours, they open the well. And the return they got from the well was 80% water, 80% water, 20% oil. What is advisable? Is it advisable to run a BHP survey? That's my question, sir. I don't know if you get me.
You mean that you finished unloading the well, and what you are seeing high water cuts.
Yes, sir.
The BHP survey is not going to tell you that you are producing water. So firstly, you want to ask yourself, is this during extended well test? Is a new well that you are testing, or a well that you know the history already? Because if you have done extended well test, you use different choke size to flow the well, and you see the behavior with oil, gas, sand, BS and W and the likes of other for the different choke size. And the commission will now give you an optimal choke size that you will use to flow the well. Is it a new well that you are doing an extended well test, or a well that has been flowing? You know the history, you know the performance. All of a sudden, you did that and you are seeing a surge in water. So we'll need to pick it up from there.
Okay, sir. It's an old well. The schematic was given, and I think you run there were wax in the well. So I think after the acid simulation was done and everything, had to do loading, loading of the well using nitrogen.
They
And the
flowed
result,
the well for a while. Was that water cut, was it consistent, or at a point it became stable?
it was not really consistent.
Because if you shut it in, immediately you notice that you shut the well in, and later again you open the well, you are still seeing that high water cut. Then you need to check. Is it that during your stimulation, you stimulated beyond your radius of investigation, your acid frac into water zone, and water find its way? So there are too many things. Maybe we'll take that one offline. We will take that one
All
offline.
right. All right, sir. No problem. Thank you, sir.
All right. Thank you. Thank you, sir. So we'll reach out to you in the chat box. Also, the other questions, Dr. Okotie will reach out to you in the chat box. So thank you to everyone who participated in the question and answer session. As we come to the end of today's technical lecture, I would like to invite Engineer Elvis Duruji, the Programs Chair of SPE Wari session, to deliver the vote of thanks and closing remarks.
Okay, please confirm if you can hear me.
Loud and clear, sir.
Okay, so good evening, everyone. On behalf of the section chair, I want to thank everyone present. More importantly, I want to thank Dr. Okotie, Sylvester. Thank you for this reaching and exciting lecture. This is what you get when classroom experience meets that of industrial. So we really appreciate you, sir. And I want to appreciate everyone, all the directors present, Dr. Eddie, his comments, input, and everyone too that have asked questions, made some remark. I really want to appreciate everyone. So SPE always creates this kind of platform for us members and other stakeholders to continuously benefit on practical situations within the oil and gas industries and others, to continue to improve ourselves, to sharpen our minds of what is happening and the new changes that are coming up. So this is a huge opportunity, and I really appreciate everyone for who have participated. And SPA will continue to create this platform so that we'll continue to learn, so that we can be resilient for the ever-changing industry and world we live in. So when we continue to sharpen our mind, continue to improve our learning, learn, unlearn, and relearn, it's SPA way of wanting us to stay abreast with the changing world. So I want to thank especially the program committee, the committee and the members that have always worked very well to see that we enjoy this technical lecture every month. Thank you very much. Let us continue to put this fire burning every month so that we can continue to enjoy the whole essence of SPA. Thank you once more, and I wish every one of us, even as we continue, we want to prepare those of Muslim brothers and sisters that we enjoy our Salah celebration very soon. Thank you all, and have a wonderful day. God bless.
All right. Thank you very much, sir. Thank you. So next we have the photograph session. So kindly open your video cameras. Bashir, you have to pass it. Okay. All right. Thank you, everyone, and see you at the next technical lecture.